Hello guys, so let us solve today's daily problem, word search 79. So basically this is a medium question. So we will be given a grade of m into n characters. So we will have to check if there exists a word or not. We will be given a word string and we have to check whether the word exists in this grid or not. Okay, so let's check the example. This is the grid and this is the word. Okay, so right. So as we can see the constraints here, the max value of m and n is 6 and the word length is 15. So, so we can approach this question by recursion. What we can do is like first find the first character of the word by brute force, and then what we can apply recursion like checking for all the four directions of the word and proceeding further until we find the last element. And we have to check for all the first character wherever we are getting the first character equal to word of 0, like in this case wherever we are getting s here, we are getting s here and here 1 comma 0 and 3 comma 1. So we will check both the uh, we will apply recursion on both cases until we get the word, and if we are not getting it then we will return false, otherwise we will return true. Okay, now I will write the code so you will better understand. So uh, int it is m comma n, right? Let us check whether the word always have some length, otherwise we will be checking 0, and if the length is not there then we will get error. So okay, so we will always be having at least a length 1. So I will create this function for checking whether all the characters of string are present, word are present or not. If it is true, then we will return true, or if it is false then nothing, we will do nothing. So what will be return time? Boolean function to find word int I j. We will pass it by a reference. So if we will also have to keep track of which character we are looking for. So we will start with one, right? Because zero is already checked. If idx equals to word dot which means we are on the we have checked all the word and we have got it, then only we have reached till the last index. So we will return true, right? So this is the condition where we stopping condition, base condition. So let us create a vector of direction global, which we will help, which will be helpful for getting the four direction. So if we check this first two indexes, we will get minus 1 comma 0, which indicates us to the left element of the grid. If we check this, if we consider it as x and this is y, similarly we will get all four directions from this array, from this vector. So so let us check. We are on this right now, 0 comma 0. So we will move in all four directions for checking for b. So 0 1 2 3, mu I equals to I plus dir I. Mu j equals to j plus dir plus a plus 1. Now we will check whether this is out of grid or not. If n I is greater than equal to 0 and n is less than, let us, is 2, we have checked whether it is valid or not, the new indexes. If board of ni and j equals to word of idx, then again we will, what we will do, we will run this function, right? We will write idx plus 1, we will be finding the next element, right? And here it will be ni and nj. Otherwise we will return false. So what we will check for all four direction, not just for one. So that is why I have written if condition here. Let us try. Okay, okay, sorry, I made a mistake here. Okay, oh, so board is basically a string. Vector, yeah. Oh, I have written here incorrectly. That is why I have getting error. This is not a string. Okay, so it's running fine. Let us check for all the test cases. Okay, we are getting an error. Let us check why. In the last case, so here we will check for the. Let us try. We have first word as is. We will check for each condition in this. Where are we getting a? Only two positions we are getting a. That is 0, 0 and 2, 0, which means first it will run for 0, 0. If idx equals to word dot size, then I is greater than equal to 0 and I is less than. A, B, C. Okay, so the problem here is we cannot visit the same element which we have visited earlier. The same letter may not be used more than once. So what can we do here? We can maintain a vector to mark them as visited. Yes, that is the one way. visited. We have initialized a vector with -1 visited. We'll use this visited here. Visited of I comma j will be 1. I comma j equals to 0. Back, we will also be doing backtracking. So we'll mark it as visited. If ni and j equals to -1, so it means like if it is not visited, then only we will we will check whether it is visited or not, and we will mark it as visited. So if we don't find it, then we will mark it as not visited. So basically we don't need it actually, because we are already doing marking it visited here. That doesn't make a difference, but okay, let's try now. Okay, okay, so now it passes all the test cases. Let us try to submit it. We're getting wrong answer. AAABCD. Input is A, and B. So it is not possible A and B. How come output is false? Oh my god. A, and B. Let us check. Oh, so actually it should be -1. I have written 0. That is why it was not checking for this condition, right? Elsewhere I written yes, here written -1. Now let us check. Now it should run fine. Okay, let us check now. Yes, we have solved it. So let me summarize it once quickly. So what we are doing is first, we will be checking for the first character of the string word in the board by doing a brute force. So when we will find it, then we will do recursion to find in all four directions like this, in all four direction, whether we are getting the next word or not, which will be idx, word of idx. And if we get that, we will also be checking whether it is visited or not here, and then we will do the recursion, apply recursion similarly for the next element. If we get till the last element and the base condition returns us true, then we will say that there is there the word exists. Otherwise, we will be getting false. Yes, this was it. Thank you.